Welcome, I'm John Butera from CEP Australia and I'm the Industry Manager for Intralogistics. Here, I'm at the Technical Competence Centre at CEP Australia and I've invited my colleague Jean-Michel so that we can take you through our Solution Centre here.
Hi John, thank you for having me here. I'm really excited to actually see what we've got, what you guys have got to show. So I suppose to start with, can you explain to me what we've got here?
Absolutely, you're welcome. So what we've got here, Jean-Michel, is we've got a camera tunnel system here and it consists of 6 cameras. The idea of the 6 cameras is that we're able to cover a parcel in every facet, so we're reading the tops, the sides, the front and also underneath as well. In order for us to do that, we need a focusing device, and the beauty about the focusing device that I've got here, which is what we refer to as our VMS systems, is that not only does it provide focusing data for the camera so that we can get accurate, smooth images, but it also provides us revenue recovery in dimensioning the parcels as well. So the idea there is that we measure the parcels and we determine the parcel is the actual size that it was set up for.
Can you please explain to me a little bit more about this revenue recovery? What does that mean to the customer?
Okay, so basically the idea with the revenue recovery process is that people are having parcels sent across the countrysides and we need to validate to make sure that they are the size that they're actually being submitted for. So in the event where the parcel appears to be of a different dimension, with a revenue recovery process in the back end, that justification is made and therefore the Courier Express Parcel Services, they then recover that revenue.
So essentially this system could be returning quite a fair bit of revenue to most of the Courier Express Post services or parcel services.
Yeah, absolutely, indeed. I mean, if you can imagine at say 13,000 parcels an hour, you imagine how many parcels go through. You'd only need a small percentage of those to be inaccurate, and unfortunately you'd lose revenue as a result of that. So therefore, whilst we're scanning the barcodes, identifying the barcodes, we're also doing the dimensioning process as well.
Given that this is a revenue recovery process that is happening here, I would think that this is actually regulated, is that correct?
Yeah, absolutely. Like for instance, what we need to take into consideration here is that the VMS systems need to be a trade-approved product, so they're a certified product. And we've got that certified by the NMI, which is the National Measurement Instrument of Australia. And obviously in other parts of the world, they've got their own governing bodies that take care of that as well. But here in Australia, we do it by NMI. In addition to the actual VMS system, we also have a scale as well. So we're able to provide dimensioning data and also the weight of the object as well.
Okay, so why the weight, John? What does that have to do?
Okay, so if you were to take into consideration that you've got a box that is probably a lot smaller in dimensions, and therefore, but it's filled with, say, ball bearings in there, so it's very heavy. So when that were to go through the scale will pick up that weight. So therefore, the greater of the object, either it being weight or in dimensions, it gets charged accordingly.
So you're saying whichever's greater is how it's being charged to that?
Correct.
Okay.
So you can imagine you might have a huge 800 by 800 mil box and it's filled with feathers.
Okay.
But it's going to take up a lot of room in the on the courier truck, so it's got to be charged accordingly.
That makes sense.
Yeah. Let's go over to this side here and I'll show you the scale as well. Okay. So as I was saying, Jean-Michel, this is where we've got the scale. So as you can see, the scale there is a inline scale. So it allows the parcels to pass through the scanning tunnel. Whilst it's being dimensioned, it's getting weight as well, and it's getting identified as well by reading the barcode.
And that is being done dynamically, right?
That is done by dynamically. So
Okay.
if you could appreciate in some of the applications out there, throughput is essential. And to keep that throughput at a high level, we need to be able to deal with speeds of, greater than 2 metres per second. So in a lot of these applications in high throughput, you'd expect to see these devices operating at say 2.5, 2.6 metres per second at least.
Which is great because it leads me to my next question. What do you find as some of the challenges out there in the industry today?
Look, absolutely. There's a few challenges there. Just to mention a few. One is, of course, parcels that are of various different colours. So you've got to consider that. The other one also is barcode quality as well. So you have a lot of instances where the barcode, unfortunately, through its travels, it does get damaged and smeared, and it can have some effects on the process. So rejects, unfortunately, can be a concern in that area. However, the technology has improved over the years, and the technology that I'd like to show you here, I'd like to go through it with you in some more detail.
Okay, so given that you showed us the camera technology before, now I believe that in the past we had a lot of concentration towards laser technology. So is the camera technology improved on the ability to read some of those poor quality barcodes?
Yeah, absolutely. The camera technology has improved it immensely. You do have a lot better gain resolution with the image quality, and therefore barcodes that are typically a poor quality in terms of the print quality, the contrast levels are much lower. You'll find that with your camera technology you overcome that situation where you were having a lot more issues with lasers. The other advantage of cameras as well is that you also are capable of reading 2D barcodes as well. So these days 2D barcodes is quite essential in the industry. As well as that, we're able to also capture the images, and when we capture the images, if there is no barcodes in that, if there's a back-end software where we do OCR, the quality of the images is very important to us.
What does OCR stand for?
OCR stands for Optical Character Recognition. So the idea there is that if we haven't read anything, we're able to identify the delivery address by looking at the postal code, delivery information there. That information is taken care of once the camera's captured the image. It sends that information off to a server somewhere where the OCR engines are sitting on and do that process. Therefore, the parcel still gets processed.
Fantastic.
So Jean-Michel, coming back to this area, I just wanted to highlight the volumetric scanners because I believe you've got a question for me on that.
Yeah, I noticed that we're on this conveyor system, we've got a lot of cuboidal boxes. So what happens in the instances where a customer has a lot of ugly shapes, different shapes, parcel, can they still dimension those parcels that are on the conveyor system?
Yeah. Okay, absolutely, good question. So with the technology, depending on your application, so in this case it's cuboidal, you're fine with a single-headed device, but in the event where we're using, say, non-cuboidal objects, parcels, satchels and so forth, ugly items as such, then we use a two-headed system. We've got a two-headed system here, and with the two-headed system here, we're able to provide dimensioning data on non-cuboidal objects as well.
Okay, fantastic. That's really good. And the limitations with regards to your ugly freight, is there any sort of limitations that customer needs to actually be aware of?
Yeah, look, typically with these, with the volumetric systems that we have today, we're able to deal with object sizes of, say, 50 millimetres in width, 50 millimetres in length, but 20 millimetres in height.
Ah, fantastic. Okay. So, John, you talked about the minimal size of the parcel that we can dimension in this case. How does it handle a larger parcel?
Yeah, look, absolutely. Good question, because in a typical application where you've got a crossbout sorter, obviously there are limitations as to what size you can measure, what size you can convey, and therefore we need to provide that revenue recovery solution, not only for sortable systems, machinable systems, but also what we call non-machinable systems. So the non-machinable systems, meaning that they cannot be put on the sorter, they'll have a direct conveyor with an inline scale, and therefore we need to be able to deal with sizes such as, say, in excess of 2.6 metres in lengthwise. We need to be able to go out as wide as, say, 1.2 metre wide, and also about 1 metre height as well.
So this is a completely separate line to their automation system, I guess, yeah?
Yeah, it's a non-machinable line that may sit in the establishment next to the sorter line as well. So obviously it caters for the ability to be able to sort the smaller objects on the machinable line, and the non-machinable line doing the sortation of the larger objects, what we also refer to as the ugly line, so to speak, because you've got all various sizes. If you could imagine, there might even be exhaust system as well. So you certainly wouldn't be able to convey the exhaust system in that case.
Okay, fantastic. Thank you.